over 2. You can't really, right? Like, there's no inverse operation, there's no way to get rid of that. So this is really, in math, kind of the preferred term. Right? So let me give you another example of this. Can I erase this part?
Yeah.
Okay. Just say no if you're not done writing. So one more example. Write this ratio as a fraction. How would you do that? London.
1 to 4 or 5 to 20?
Okay. Yeah, so we could just write it like this, but that's also equal to 1 to 4. Yeah. So ratios, just like fractions, can be reduced. So 5 over 20 is equal to 1. Yeah.
And does it matter if we do 5 to 20? Do we have to simplify it?
In this case, it would be fine if you just wrote 5 to 20. Because all I said was write this as a fraction. I didn't say in simplest form. I didn't say reduce it. Right? So in this case, this would be a fine answer. You could simplify it. Okay. So that's what a ratio is. Can I erase all of this?
Yeah.
You guys got the definition and the example? The next thing we're going to talk about is a proportion. Proportion. Does anyone know what makes a ratio different from a proportion? What is a proportion? What's a proportion? Gideon?
It's a small amount of a larger number. Say you've got a full meal with 7 dishes, but you only try 5 of them, and that would only be a proportion of the full meal.
That's a portion, right? So without this part. So what's a proportion? Yeah.
The size.
Size. Okay, so we're getting at maybe the root of the word. But in math, it has a really specific definition. Okay? A proportion is the equality of 2 ratios. Okay. So what we just wrote on the board, the last thing we wrote in that last example, was actually a proportion. Let me give some examples because that's a really confusing definition, I think. Well, let's look at this. 4 over 2 equals 2 over 1. That's an example of a proportion. Okay. Another example. 3 over 6 equals 6 to 12. Right? That's one way we could write a proportion. Now in math, you're not going to see them written like this a whole lot. But it's just good to know what this means. Yeah.
So proportion is basically 2 ratios, but they equal the same thing?
Yeah, 2 ratios that are set equal to each other. Yeah, that's like maybe a better way to say the definition.
So they're kind of equal in a way?
Yeah. So let's write that actually. 2 ratios that equal each other is a proportion. Good way of saying it. I like that definition a lot better. Okay. Now the cool thing about proportions is there's like a trick to solving them and to making sure they're equal. In this case, we're not going to put any variables in them yet. When you have variables, then you solve for the variable. But what we can do is we can cross multiply. And that'll just help us to check if these things are equal. So cross multiply. This is cross multiplying. Ready? We have 1 over 2 equals, let's say 3 over 6. To cross multiply, we're going to take the numbers that are across from each other in the proportion. and we're going to multiply them. So I'm going to do 1 times 6 equals 2 times 3. And then what we do if we simplify this, 6 equals 6, and we could say this is true. So that's what cross multiplying means, is taking the numerator times the opposite denominator and the denominator times the opposite numerator. Let's do some examples of that.
Stop.
I don't know what happened. Yeah, there's some sort of update came up. I don't think it recorded anything. I don't know. It's hard to tell. Oh no, it's still recording. 6. So it's recording all of this. Perfect.
That's embarrassing.
Okay.
Video editing time.
All right. Another example.
Man, you just made a fool out of yourself.
I know.
Jeez.
Wouldn't be the first time. So 3 over 7 equals, let's say 30 over 70. And if I said cross multiply to check, what would you do? Ben.
You would multiply 3 times 70 and
Okay.
7 times 30.
3 times 70, and so plus, you said and 7 times 30?
Yeah, and, no, yes, and 7 times 30.
So it's 3 times 70 plus,
No. So I meant 3 times 70 equals
Equal.
7 times 30.
okay. So this equals is really important. We can't lose our equals. 3 times 70 equals 7 times 30. If we multiplied those out, 210 equals 210. That's true. I'll write a T for true. Yeah, good.
Could we also take off the zeros on 70 and 30 and then add the zeros
Sure,
and
you
add
could
the
have.
answer?
Another way to check this would have been just to reduce this one, right? That would have been fun. But that's not what I asked you to do, right? I said just cross multiply. Example. What if I wrote it like this? So let's do a first step before we try to cross multiply, right? Like we did up there. What should we do to make it a little bit easier? Lila. Let's turn this into a fraction. So what would the fraction be? Luca?
2 over 5.
2 over 5. So then we have 2 over 5 equals 4 over 10. Now we can cross multiply a lot easier. 2 times 10 equals 5 times 4. 20 equals 20. True again. Any questions about any of that?
That's it right there.
Gary.
So this is really cool. I'm seeing a pattern that whenever you have two ratios equaling each other, they always equal the same thing. Am I right?
What do you mean? I'm sorry.
I mean, you got, it's like it always equals 20 equals 20, and 10
Oh,
equals
sorry.
10, and 6 equals
Try
6.
looking at your neighbors.
I
I think I know what Gary's saying.
Does it always work out that way?
Not always.
Let's try another example. Let's try what would maybe be considered a counter example. What if we had this? Okay. What's our first step going to be? Let's write them as fractions. So Shelby. Good. And plus?
Or equal.
It's good. It's all right. Okay. 7 over 3 equals 3 over 9. Now let's cross multiply to to check this one. We could reduce this, but we're not gonna. We're just gonna cross multiply. What do we have, Andrea? 7, not 7 nines, but 7 times 9, right? So remember, we're cross multiplying. So 7 times 9. Good. Hold on 1 second. And then what's our middle thing going to be, Andrea? Just like it was up here. We just did our multiplication. In between, we have an equals. See that? We have to keep this equals, just like we had it up there. And then we're going to cross multiply what'll be on the other side. This one times this one. Very good. So 63 equals 9.
What?
Was that true?
That's preposterous.
False. Right? So this proportion is not true. Right? It's false. Either that or we just all learned something new today. 63 equals 9. That will be your homework. Ben.
So, basically, if it's so, never mind.
Okay, Lucas.
Is there gonna be questions like this on the homework?
Yes, the homework will be this type of
And
question.
are we supposed to write true or false on it?
Yes. And show your work.
Oh, okay. I thought that we actually had to come up with the original answer and not true or false.
No, so you'll just do the cross multiplication and then write true. Yeah.
If we reduce the 3 over 9, would it be 1/3?
Yes. If you had reduced this, that's really good. It would have been 1.
Would it make the answer different?
Let's check. Would this make the answer different? So if we had 7/3 equals, instead of 3/9, if we had 1/3, would this make the answer different? Andrea, do you want to tell me how to cross multiply this one? Okay.
Okay, so 7 times 3 is 21.
Uh-huh.
And then 3 times 1 is 3. So 21 equals 3.
21 equals 3. Still not true. Right. Still not true. It doesn't really change the answer because if you look at this, 63 is 3 times 21 and 9 is 3 times 3. So when we reduced this by dividing by 3, we just kind of reduced our answer as well. Yeah. It doesn't change the answer to reduce.
Is our homework going to be double-sided?
No. Let's do tomorrow. We're going to practice cross. Yeah.
Isn't there also like cross multiplying?
Cross-canceling, people call it sometimes, right? Yeah, let's not go too far into that today because it could get confusing. I just want to do one more problem. Yeah.
So, just to clarify, in order for the answer to be true, both the answers for the cross multiplying have to be the same.
Right. What if we had this? What if we had a problem like that? Ben.
Then you would just multiply -3 times positive 49.
Okay. And?
Then it would be equals 7 times 21.
Okay. -3 times 49. Is my answer going to be positive or negative? Negative. Negative times a positive is going to be negative. 49 times 3, I'm going to do that over here. 27. 3 times 4 is 12, plus 2 is 14. Negative 147 equals 7 times 21. Let's do that over here. 7 equals 147. Is that true?
No.
No. Why not?
Negative
Because it's
Opposite sides of the spectrum.
Yeah, they're opposites, right? This is the opposite of the opposite of 147, and this is 147. So they're not equal because they're opposite. So we would write F for false. Thank you. Any questions? Yeah.
Is there going to be negatives on homework?
I don't believe there are any negatives on the homework.
I see it.
It's coming around.